It's the start of another day at my restaurant, and I'm gathering the freshest ingredients before I begin cooking. Oranges are great to add tang to any dish.
Oranges are tangy because of the acid they contain. In fact, the word acid comes from the Latin word acidus, which means sour. By the end of this lesson, you will be able to define an acid, define organic and inorganic acids, explain the physical and chemical properties of acids, explain how indicators help to identify acids, list the uses of acids. Any substance that releases hydrogen ions when dissolved in water is an acid. A hydrogen ion cannot exist on its own, so it combines with a water molecule to form a hydronium ion. For example, hydrochloric acid when dissolved in water liberates a hydrogen ion and a chloride ion. The hydrogen ion combines with water to form a hydronium ion.
This curd is too sour. It needs a little sugar.
Curd contains lactic acid, which gives it a sour taste. Acids obtained from food like curd, lemons, grapes, raw mango, citrus fruits and gooseberry are called organic acids. Hydrochloric acid, sulphuric acid and nitric acid are called inorganic or mineral acids. We already know that acids taste sour. Acids also have other physical properties. Acids turn blue litmus red. They also turn methyl orange red. Acids have a corrosive action on the skin. Sulphuric acid stains the skin black. Nitric acid stains the skin yellow, and hydrochloric acid leaves an amber stain on the skin. Acids are good conductors of electricity. Let's try to prove this through an experiment. Pour 5 ml of hydrochloric acid into a beaker containing 10 ml of water. Suspend 2 carbon rods in the acid. Connect the rods with an electrical wire in series along with a battery, a switch and a bulb. Switch the setup on and see the bulb glow. This shows that acids are good conductors of electricity. Mixing an acid with water reduces the concentration of hydronium ions of the acid per unit volume. This is called dilution of acid. Acids generate heat when they are diluted. This is because the action of acids with water is exothermic. Take 5 ml of water in a test tube and carefully add sulphuric acid to it. Now shake the test tube and touch its base. The base will feel hot, indicating that a reaction between acid and water is exothermic.
I never store tomato soup in a copper pot for very long. It gives the soup a funny taste.
Tomato soup, being acidic, reacts with copper, and that is what causes the change in its taste. Acids react with metals to form metal salts. In this reaction, hydrogen gas is liberated. Take a few granules of zinc in a test tube. Add 2 milliliter of sulphuric acid to it. You will find that a gas will be liberated. Bring a burning splinter close to the gas liberated. The splinter burns and a pop sound shows the presence of hydrogen. Acids react with metal carbonates to form corresponding salts, carbon dioxide and water. Try this experiment. Take 1 gram of magnesium carbonate. Now pour 2 ml of hydrochloric acid into the test tube, you will observe that a gas evolves. Pass this gas through freshly prepared calcium hydroxide solution, also known as lime water. Lime water turns milky, proving that the gas is carbon dioxide. The precipitate formed in this process is calcium carbonate. Acids react with metal hydrogen carbonates and form corresponding salts, carbon dioxide and water. Take 2 grams of sodium hydrogen carbonate in a test tube. Pour 2 milliliter of hydrochloric acid into the test tube. You will see that a gas evolves. Pass this gas through freshly prepared lime water. The lime water turns milky, indicating that the gas evolved is carbon dioxide. A white precipitate of calcium carbonate is also formed. Acids react with metal oxide to form salt and water. Let's conduct an experiment to prove this chemical property. Take 10 milliliter dilute hydrochloric acid in a beaker. Add 2 grams of copper oxide to the beaker. Stir the mixture continuously. You will find that the black copper oxide disappears and a blue-green solution is formed in its place. This blue-green solution is copper chloride. An acid-base indicator is the one which exhibits different color in acids and bases. Red cabbage is a visual indicator used to detect acids. The cabbage leaves are purplish in color but turn red in the presence of an acid. Onions are called olfactory indicators because of their characteristic smell. This smell is destroyed by the action of a base. The most common indicator that you may have come across in the laboratory is litmus, which can be in the form of a solution or paper. Litmus is a natural indicator and is extracted from lichens. It is dyed blue and red to detect changes in color. Take 1 milliliter of any acid and put it into a watch glass and then place a red litmus paper in it. There is no change. In the same setup, place a blue litmus paper and see what happens. The litmus paper will turn red, indicating the presence of acid. This shows that acids turn blue litmus red. Apart from natural indicators, there are a few synthetic indicators such as methyl orange and phenolphthalein. The neutral color of methyl orange is orange and it turns red in an acid and yellow in a base. Phenolphthalein is colorless. It does not change in an acid but turns pink in a base. Acids have various uses. Sulphuric acid is used in the manufacture of fertilizers, paints, dyes, chemicals, plastics, and synthetic fibers. It is also used in car batteries. Nitric acid is used in the manufacture of fertilizers, explosives like TNT, dyes, and drugs. Hydrochloric acid is used before galvanizing to remove oxide film from steel and also as a descaling agent for boilers. It is also used in the textile, leather, and food industry. What's the matter, Sam? You look pale. Is something wrong?
I have overeaten, and now I am feeling some uneasiness in my stomach. What should I do?
This problem is known as acidity, which is due to excessive intake of spicy food. This acidity of food is relieved by using an antacid, which is a mild base like sodium bicarbonate. A mild base neutralizes the excess acid produced in the stomach and makes you feel relieved. In this lesson, you will learn about properties and uses of bases. At the end of this lesson, you will be able to define a base, explain the physical and chemical properties of bases, explain how indicators help to identify a base, and list the uses of bases.
Tell me more about a base.
Any substance that can produce hydroxide ions when dissolved in water is known as a base. For example, sodium hydroxide, when dissolved in water, dissociates into sodium ion and hydroxide ion.
How can one identify a base? Do they have any unique properties?
Yes, they do. Bases can be identified with their physical properties. For example, they are bitter to taste. But you must never taste a base, as strong bases are corrosive in nature and denature the protein.
What are these colored strips of paper? What are they used for?
These colored strips of paper are called litmus paper. Bases turn the red litmus to blue. Apart from litmus paper, we can use methyl orange. On addition of methyl orange to a base, like sodium hydroxide, the orange color of methyl orange changes to yellow, and when phenolphthalein is added to sodium hydroxide, it changes to pink.
It's slippery. It feels like soap.
Bases feel soapy on touch. This is because they dissolve the fatty acids and oils from the skin, and it reduces the friction between your fingers as we rub them together. Due to this property, bases are used in the preparation of soaps.
What is this?
Bases are good conductors of electricity in aqueous solution. In aqueous solution, they release ions which conduct electricity. To prove this, let's perform a small experiment. First, we take 10 milliliters of sodium hydroxide solution and 10 milliliters of water in a beaker. Then, we take a cork and fix 2 carbon rods in it. Next, we connect the rods with an electric wire in series, along with a battery, switch, and a bulb. Now, we insert the setup into the beaker with sodium hydroxide. Finally, pass electricity through it. We can observe that the bulb glows. From this, we can conclude that bases conduct electricity.
Ouch! It's hot!
When bases are diluted with water, they give out heat. Let's look at this experiment. We take 5 grams of sodium hydroxide pellets in a test tube. To this, we add 10 milliliters of water slowly by stirring. On diluting with water, some heat is released, due to which the test tube becomes warm. Let's observe the chemical behavior of these bases.
Chemical behavior?
Bases react with some metals, like zinc, and liberate hydrogen. For example, when sodium hydroxide reacts with a metal like zinc, it liberates hydrogen gas along with the formation of sodium zincate.
I don't see any gas. How can you say it's hydrogen gas?
The liberated gas can be tested with a burning splinter, which is put off with a pop sound indicating the presence of hydrogen gas.
What's next?
Bases react with non-metallic oxides to form salt and water. This is very similar to a neutralization reaction between an acid and a base. From this, it can be concluded that non-metallic oxides are acidic in nature. Consider an example. When carbon dioxide gas is allowed to pass through calcium hydroxide, it results in the formation of calcium carbonate and water. Now, can you tell some of the uses of bases?
Yes. Bases neutralize the acidity caused in my stomach.
Not all bases, only mild bases neutralize the acidity. Apart from that, bases have a variety of uses in daily life. Let's look at some of them. Bases like sodium hydroxide are used in the manufacture of soaps, paper, and synthetic fibers like rayon. A base like calcium hydroxide is used to manufacture bleaching powder. Bleaching powder is used as a disinfectant. Magnesium hydroxide is used as an antacid to neutralize the acid produced in the stomach. This is similar to the one you have taken to obtain relief from your acidity problem. Bases are useful to plants too. A base like ammonium hydroxide is used in the preparation of fertilizers like ammonium phosphate and ammonium sulfate.
I wish there was a more interesting way to remember acids and bases. Yeah.
I can make this an interesting game for you. It's called Treasure Hunt. Would you be interested?
Yes, very much.
Welcome to the Acids and Bases Treasure Hunt. In this park, you will find several items marked with a red dot. Some of these are acids and some are bases. Tina needs to find all the acids that are hidden here, while John has to find all the bases. The one who finds the most number of items before the time is up will be the winner. In this lesson, you will learn about indicators and their role in identifying acids and bases. By the end of the lesson, you will be able to define acids and bases and classify substances into acids and bases. You will also be able to define indicators and describe their effect on different substances. In addition, you will be able to define acid rain and describe its impact on the environment. Before you start, you will need to know what acids and bases are. Let me explain. Many substances that you encounter in your daily life have different properties. One major difference between substances is whether they are acidic or basic. Acidic substances taste sour. Some examples are curd, lemon juice, tamarind, spinach, and vinegar. These contain natural acids. Basic substances taste bitter and feel slippery to the touch. Some examples are baking soda and milk of magnesia. All right, get, set, go!
I found something with a red dot, but I wonder if this is acidic or basic. How do we find out?
Let me help you. There are special substances that are used to test whether something is acidic or basic. These substances are called indicators. Indicators change their color when added to an acidic or basic solution. Some natural indicators are litmus, turmeric, and China rose petals. I have some litmus solution here. Litmus is a natural dye extracted from lichens. It is the most commonly used natural indicator. Notice the color. It is a light mauve solution in distilled water. Do you want to see how it works? See how the color of orange juice solution changes when I add the litmus to it. See, the solution turns red. This means the orange juice is acidic. If it were basic, then the color would have changed to blue instead.
This is great. We have found our first acidic substance. Thank you, Mr. Wees.
You're welcome. Let me see how John is doing.
Looks like I found something. I wonder if this is an acid or a base.
Hi, looks like you found a bar of soap. To find out if this soap is an acidic or basic substance, put a strip of wet red litmus paper on it. The red litmus paper has turned blue. This means that the substance is basic in nature. If it were acidic, the color would have remained red. Soap contains sodium hydroxide or potassium hydroxide, which are basic in nature.
Thank you, Mr. Wiz. Hey, I found another item. Let's test to see if it is acidic. Let's use these strips of litmus paper to find out. The blue litmus paper is still blue. Let's test with the red one. The red strip has turned blue. That means it is a basic substance, not acidic. If it were acidic, it would have remained red.
I found a lemon.
You've tasted a lemon before, haven't you? What does it taste like?
It tastes very sour.
That's right. It's sour. And one of the properties of acidic substances is that they are sour in taste. Let's confirm that this lemon is acidic using the strip of blue litmus paper. It's acidic. This is because it contains citric acid. Here you go. One more item for your bag.
Look, I found something. The label says this is lime water. I wonder what that is. Is it acidic or basic? Look, I found something, but I don't know what it is.
Ah, this is lime water. It is made by dissolving some lime in water and allowing it to stand for some time. We must test this with an indicator to check what it is. We have been using litmus as an indicator. Another natural indicator is turmeric. Let's try that now. I have made these strips of turmeric paper by spreading some turmeric paste on the paper and drying it.
It's changing color.
That's right. Turmeric changes color to indicate acidic and basic substances. It is yellow in acids and reddish-brown in bases. Lime water contains calcium hydroxide, which is a base. That is why the turmeric is turning reddish-brown. Looks like you have another item for your bag.
Oh, I wonder what this is. Looks like vinegar. I wonder if this is acidic. Let me taste it to find out.
Wait, don't do that. You should never taste anything that you're not sure is safe. it may be harmful to you. Let's test this with turmeric to see if it is acidic or basic. There is no change in the color. It means this is an acidic substance. If it were basic, it would have changed to reddish-brown instead.
Thank you, Mr. Wees.
Wow! Another item.
Do you know that there is another natural indicator that we haven't tried yet? It is called China Rose. Here is a solution that I have made with some China Rose petals and warm water. This will tell us if the baking soda is acidic or basic. See how the China Rose solution has turned green? This means it is a basic solution. If it were acidic, it would have turned bright pink or magenta instead. Time's up, children. I hope you found lots of stuff. It's time to count what you have. Let's see what you have, Tina.
I found 3 things. Some orange juice, a lemon, and this bottle of liquid, which we think is vinegar. We have tested each of these to confirm that they are acids.
That's right. You must have at least 4 items in your bag to win.
Yes! A soap, milk of magnesia, lime water, and some baking soda solution.
Congratulations, John. You have won this game. Well, that was fun. Let's recap what we learnt out there in the park. Many substances we encounter have either acidic or basic properties. Acidic substances are sour in taste. In fact, the word acid comes from the Latin word acer, which means sour. Basic substances are bitter in taste and slippery to touch. Indicators are substances used to test whether something is acidic or basic. Different indicators react differently to acids and bases. Indicators change their color depending on whether they are added to an acidic or basic substance. Some natural indicators are litmus, turmeric, and China Rose. Even if you haven't heard about different acids, you may have heard the term acid rain on the news or on TV. Acid rain is rain that contains a lot of acid. This acid is created when pollutants in the air such as carbon dioxide, sulfur trioxide, and nitrogen dioxide dissolve in rainwater and form acids like carbonic acid, sulphuric acid, and nitric acid. This rain causes a lot of damage to buildings, plants, and animals. This is one important reason why we must avoid polluting our atmosphere.